Hi everyone, this is a continuation on our lesson on expressing the concentrations of solutions in different units. So we are still on learning target number 3, okay? And then in the previous video, we were talking about molarity. So this time, let's talk about another unit of concentration, which is molality, represented by small letter m, which is the number of moles of solute per kilogram solvent, right? So what differentiates it from molarity is that we are dividing the moles of solute with the kilograms of solvent. Now, this is more advantageous if you want to have stable sampling because the mass of substances do not necessarily change with temperature, so it is not temperature dependent. Whereas for molarity, so since we are talking about volume, uh, volume is in a way affected by temperature, right? Because if you heat liquids, they tend to expand, the particles move away from each other. Okay, so that's why we also use or take into consideration molality. Again, that's moles of solute per kilogram solvent. So in this example here, we are given uh, we are given the problem: what is the molality of a substance that contains 128 grams of methanol? So this is methanol with a molar mass of 32.04 grams in 128 grams of water. So take note that, wait, take note that in getting the molality, we have to convert grams into the number of moles, all right? And divide everything with the kilograms of solvent. So the first thing that we have to do is to identify which one is our solute and which is our solvent. Since we see that water is present at a greater amount, then we can say that water is our solvent. Okay, and our solute has to be converted into the number of moles. So we can write this way: M is equal to 128 grams of methanol, CH3OH. Then we need to cancel grams, so we can use the molar mass. So we have 32.04 grams of methanol. And on top is the number of moles, okay? 1 moles of CH3COH. Then we can cancel grams of methanol, cancel grams of methanol. After that one, we know that the unit moles methanol will be left. So by then, we can divide everything with the kilograms of your solvent. Since we are given 208 grams of water, then therefore we still need to convert grams into kilograms. So we just divide it with 1,000. So 1,000 grams is to 1 kilogram. Or you can place it here directly. Just write 0.208. So decimal point 3 times to the left. So we have the following equation now. That's 128 divided by 32.04. That's equal to an answer here. Then we divide everything with 0.208. So we have 19.20, 19.2, and then molal. Okay, so the unit there is set as our molal. Okay, so if it's for molarity, it's molar, then the unit is in molal. All right. We don't forget the label also, CH3OH. Right. So going back to our example. So here we are asked to find the mole fraction of methanol in a solution that contains 32 grams of methanol and 36 grams of water. Okay, and here we are asked what the mole fraction of water is. All right, so it's water, that the mole fraction of water that we will be looking for. Okay, so if you remember, the equation for mole fraction is X, and then we place the subscript H2O is equal to the number of moles of H2O divided by the total number of moles. So as for this case, it's moles H2O plus moles of methanol, okay, CH3OH. All right. So what we do have is, or are the masses of water and methanol. So we need to convert them to moles first. All right. Since in the numerator we can use 36 grams of H2O and then convert it into moles. So this is 1 mole H2O over 18.02 grams of water. And then we can cancel grams of water, cancel it here. Okay, that's 36 divided by 18.02. So we are left with the moles of H2O. Now our denominator is quite long since this is the sum of water and methanol, okay, the number of moles. So first is we can copy this. That's 36 grams H2O times 1 mole H2O over 18.02 grams, right? So this is basically looking for the mole, the number of moles of water, but don't forget that we need to add the number of moles of methanol. So from our given, we have 32 grams of methanol, 32 grams CH3OH, and then we need to convert it into the number of moles, so we can use the molar mass of methanol. So this is over 32.04 grams is to 1 mole. That's CH3OH. All right. So you notice that once we cancel out the units, we end up with numbers of moles of ethanol plus number of moles of water. So you can do this directly. You can input it directly in your calculator, especially if you have the fraction notation, or you can do this separately. So this is 36 divided by 18.02. You have an answer in the numerator, and then you can also perform the calculations in the denominator and then just add. So our answer here is 0.6666 something, okay, but we don't like that number, so we end up with 0.67. All right, and then since the number of the unit moles are present, then we can just have a unitless quantity, that's 0.67, okay, because moles get cancelled out. Okay, therefore the mole fraction of H2O is 0.67. And then if you are asked for methanol, then you can just have XCH3OH is equal to 1 minus 0.67. Then that gives us an answer of 0.33. 0. Alright? But what is asked in the problem is this one. Okay, so that is mole fraction, right? So the number of moles of our desired substance and over the sum
or the total number of moles in that particular solution. Right? Now, we can also do some operations on molarity and molality. All right? So in the exercises later on, it will be given, you might be asked to convert molality and molarity. So what makes it possible? What makes the conversion possible? We need to know the density of the solution. Okay? So we can calculate molarity and to molality, or do the conversion if we have the density of the solution. So stay tuned for it in the more examples video. All right. So that would be all for this video. Thank you very much for listening.